Good morning everyone, I'm John and my teammates are Teja and Michael. Here is our table of contents. Firstly, I will introduce our motivation behind this project. Secondly, each of us will present our exploratory data analysis. Thirdly, each of us will present the ML model we worked on, and lastly, Michael will present our outcomes and insights. So, why football? Apart from it being the most popular sport in the world, sport betting is also highly infamous and lucrative in nature, making it an attractive domain for us avid football fans to work on. After much hunting on Kaggle, we decided to use the English Premier League dataset by Saif Uddin. It contains a comprehensive dataset with detailed analysis on match factors and statistics from 2000 to 2018. To put it simply, we want to investigate the factors which contribute to a team's performance in terms of winning and losing games, and use ML models to predict future matches based on past matches. Furthermore, we also try to predict the top 6 teams for the 2017 to 2018 season based on data from 2000 to 2017.
Now moving on to our data cleaning process for predicting the Premier League table. Firstly, we decided to keep only those teams that have been part of the English Premier League for 2017 to 2018, since that is the year for which we are going to predict the table, which makes up to 18 teams in total. By excluding the teams that were not part of the season, we aim to improve the quality of our prediction and provide more reliable insights into our outcomes of the league. We made the decision to exclude the Match Week 1 dataset because it lacked important information that had a significant impact on the outcomes, such as the form of the teams and the point difference between the teams. This is because the teams had not yet played any matches, and as a result, their form could not be computed at that stage of the season and they were just null values. Next, we split the dataset into two parts, 2000 to 2017 for training and testing of the dataset and 2017 to 2018 for predicting the Premier League table. This was done to ensure that we had sufficient data to train our model and to validate its accuracy. The calculation of our correlation coefficients with all the available factors against the dependent factors led us to conclude that there were 6 factors that had a high impact on predicting the 2 resultant variables, since they had a high correlation coefficient values. This is the heat map to check the relationship between all the 6 predicted factors and the response variables. Now moving on to the exploratory analysis, where we formulated 3 questions as shown in this slide to explore, gain insights from the dataset and solve our problem statement. Now moving on to the first question, which is whether home field advantage plays a big factor in match performance. To answer this question, we created a comprehensive table that highlights the significance of home and away matches by presenting key metrics such as goals scored per match, goals conceded per match, and win percentage for both home and away teams. Through this extensive analysis, we were able to gain a deeper understanding of the impact of playing at home versus playing on away on team's performance. Thus, the answer to our question is yes. From our statistical analysis of all the teams over the past 18 years, it is clear that the home goals per match are always greater than the away goals per match. We can also see a drastic difference between the home win percentage and away win percentage, which describes that all the teams perform better on their home ground than away grounds.
The second question to be explored is determining goal difference and how it affects the football team's performance overall in the league. Generally in the table, you can see that while GD per season decreases down the rows, the points per season and win percentage also decreases down the rows. However, there's some exception in the trend. You can see that Chelsea has a higher goal difference compared to Man United, but Man United has a higher points per season and win percentage. This means that Man United performs better than Chelsea even though they have a lower goal difference. Newcastle, on the other hand, they have a lower goal difference compared to Southampton, but it has a higher point per season or ranking. Hence, Newcastle with lower goal difference has better performance. The reason behind the exception are that different play style, strength of opponent, goalkeeper performance, and luck. All these factors make the GT values vary. All in all, GT gives a positive correlation to a team's performance, albeit having some exception. Overall, the team with the highest GT, Chelsea, is ranked second from top, while the team with the lowest GT, Watford, is ranked at the very bottom. Consequently, this shows how GT is a fairly good indicator to the team's performance.
So the third question analyzes how much impact a team's form has on its likelihood of winning a match. Form effect percent describes a team's chances of winning if it had less form points than its opponent. This is calculated by having the number of times a team wins with lower form points divided by the number of total wins by the team. From the table above, we can see that the form effect percent is considerably low, which is less than 50% for most of the teams. This shows that form points have an impact on the team's likelihood of winning a match. Some teams have higher percentage of form effect percent as they face teams at risk of relegation or newly promoted teams like Brentford and Brighton. These weaker teams have played very few matches in the EPL and hence are less experienced, causing them to lose more easily to teams with higher form effect percent. A possible reason behind this low form effect percent for top teams like Man City and Man United is that form effect percent only considers if a team wins games when form points are lower than the opponent. And since top teams tend to have higher form points than weaker teams, they will have lower form effect percent since they hardly lose any games.
Now moving on to our machine learning. For the first, in our question to predict the Premier League table, we have employed the use of 3 machine learning modules. We chose linear regression in the first place to solve the problem, as it is the machine learning technique used for predicting numerical values, and since our problem deals with lots of numerical data such as predicting the scoreline, we believe that linear regression can help us uncover valuable insights. Since our motive is to predict the final point table using the numerical values, we use the 6 chosen predictors to predict the full-time goals scored by the home team and full-time goals scored by the away team, such as FTHG and FTAG in a match. By predicting these values, we were able to calculate the results for all the matches across the season, thus enabling us to determine the complete point table. To analyze the relationship between FTHG, FTAG and the 6 selected factors, we created a correlation matrix which is displayed on the slide. This is the correlation matrix for predicting the FTAG. Now, upon analyzing the outcomes of our linear regression analysis, we were able to generate the table that showcases the actual and predicted rankings of each team. We noticed that the majority of the teams were actually placed in the table, indicating that the model placed proficiently. However, we did observe a few instances where certain teams switch places in the table, which could be due to the fact that these teams have had limited participation in the Premier League over the past 17 years, leaving us with insufficient data to generate the precise results for them. Accuracy of our prediction is calculated using the mean square error and root mean square error as shown in this figure. Overall, we can confidently say that linear regression is a valuable machine learning technique for predicting the Premier League table, and we will continue to use it alongside with other algorithms to enhance our predictions.
Before we begin with neural networks, let's explore how does neural network actually work. Neural network works by splitting nodes into input layers for independent variables, hidden layers, and output layers for dependent variables. In its core, the hidden layers have mathematical function to train the system to recognize the trained input and send out trained output. And once it has been trained, it can now predict values by passing any input to the network to receive the predicted output. To begin with, we will start applying a neural network for one team versus another team before moving on to the whole league. Looking at the first arrow, you can see the dependent variables FTR, where 0 is home win, 2 is away win, and 1 is draw. The independent variable used to predict are FTHG, FTAG, and etc. as my friend has discussed. And we will model the neural network based on TensorFlow class API, and the mathematical function will be based on this using the 3 hidden layers. After which, we can see the training set is set to be 500, and each time it's trained, the accuracy prediction increases, seen from increasing from 0.07 to 0.5, 0.7, and finally to 1. Do note that it may not always reach 1 fully. And afterwards, we can run the model on a set of inputs to check the predicted values through probability distribution. We use data from 2017-2018 season as input, and we can see that it accurately predicts Arsenal winning the match against West Ham, and which happened in real time. Now we will see apply the same method on all teams 1 versus 1 every time, and this will take quite some time. But when the end results show, we can see that there is a predicted state and the certainty according to the earlier probability distribution. By using the earlier method of ranking, we can see how the predicted table compared to the original table. And we can see that generally the teams are quite well predicted, shown by the small root mean square error of 4.546. Hence, we can see that neural network gives a fairly good prediction to football teams' ranking.
I'm in charge of random forest regression. Firstly, I set the factors to be predictors and full-time home goals FTHG to be the response. Here is the graph as shown for n estimators, or 3's equal 100 and 1000 respectively. By comparing the results, the explained variance increases and the mean square error decreases, showing a more accurate prediction. Next, I set the factors to be predictors and full-time away goals to be the response. Here's the graph as shown for n estimators, all 3's equal 100 and 1000 respectively. By comparing the results, the explained variance decreases and the RMSE increases, showing a less accurate prediction. The less accurate prediction for FTAG is odd, as the improvement of model is expected when the value of n estimators is increased. One possible reason why increasing the number of estimators does not always lead to better performance is overfitting. As n estimators increases, the more complex model can memorize noise in the training data, leading to overfitting. In this case, it may perform well on the training data, but its performance on the test data may degrade. While decision trees can capture non-linear relationship between the predictors and response, random forest regression can still struggle with certain types of non-linear patterns. In this case, increasing n estimators may not improve the model's performance. Hence, this model works better in predicting FTHG than FTAG. However, we can still use the random forest regression method to predict the ranking.
To recap, we can see that the various machine learning model could model the ranking model of different teams. You can see from the RMSE that neural network is best, followed by random forest, and finally linear regression. The reason behind this is because neural network can model highly non-linear data relationship of variables and use regression technique to prevent overfitting. In addition, recalling our personal objective of the 6 teams, we can see that the 5 teams are consistently there, and we can expect this team to qualify for champion of Europa League. In conclusion, we managed to learn that through this, our relationship, we managed to identify the crucial variables and successfully use true machine learning to predict future football ranking. Thank you for listening to our presentation.